You click a link to visit a site like net22.cc, expecting it to load instantly. Instead, your momentum slams into a stark white screen. Most of us let out a frustrated sigh when this happens. We assume a slow server, a weak Wi-Fi connection, or a temporary network glitch is delaying our request. That blank white page with the spinning circle is actually an active, heavily armed digital checkpoint. This pie chart of global internet traffic reveals why checkpoints exist. The digital world is split in half, with 50% generated by non-human bots. This swarm is busy, scraping data for AI, flooding forms with spam, and launching DDoS attacks to break servers. If every website left its front door wide open, their servers would crash instantly under the sheer weight of this automated traffic. They require a bouncer at the door. To understand how the internet survives the invisible interrogation, the verification screen begins its work with a simple status update, performing security verification. This topological map illustrates exactly what is happening in that fraction of a second. A security provider like Cloudflare has physically stepped between you and your destination server to intercept the connection. 10 years ago, passing a security check meant proving your humanity by manually identifying objects in a blurry grid of photos. Today, the system bypasses you completely and interrogates your browser directly. The parameters of this test are listed in the tiny text near the bottom of the page. Enable JavaScript and cookies to continue. This exploits a very specific limitation in how hackers operate. To launch millions of these attacks quickly and cheaply, bad actors rely on automated programs called headless browsers. They strip out heavy, resource-intensive features like JavaScript so their bots can move as fast as possible. This trap forces your browser to instantly compute a complex math problem using JavaScript. Simultaneously, the system scans for persistent session cookies. Because bot scripts launch from an empty cache to save resources, they lack the long-term data markers of a legitimate browsing history. Cheap automated scripts simply lack the processing power and the behavioral state to pass these tests. The mundane act of running a fully featured normal web browser serves as the definitive proof of your humanity. Down at the very bottom of the verification screen sits a string of alphanumeric characters labeled Ray ID. This unique string of text serves as a digital receipt for this specific micro-interaction. This security verification runs across a sprawling edge network of thousands of distributed servers, automatically routing requests to your closest geographical location. The Ray ID logs this performance and traces your exact pathway through the global network. In this case, A01C4074 F973 DED0. If a connection passes the initial test, but later attempts a sophisticated attack, that ID provides a perfect forensic footprint. Security engineers use it to track the threat and block it across the entire globe instantly. The math problem is solved, your cookies are verified, and your fingerprint clears the database. The screen updates one final time. Verification successful. Waiting for net22.cc to respond. All of that complex interrogation, the cryptographic math, and the routing through global edge servers took place in the literal blink of an eye. We have moved far beyond the era of internet security that forced users to squint at blurry fire hydrants and crosswalks to prove their worth. We operate in an environment where our software vouches for us, working silently in the background. That mundane 3-second loading screen operates as a highly efficient filter, quietly absorbing the impact of millions of automated attacks, so the websites we rely on can keep their doors open.